When we have any kind of fraction where we have a function of x on the top and a function of x on the bottom, and then it's bigger than something or less than something, then generally we have to treat it as a rational expression. Now what that means is that we've got to look at when the top is equal to 0, in this example here, when the top is equal to 0 and when the bottom is equal to 0. So we need to have it less than 0 first or more than 0, and then look at when the top is 0 and look at when the bottom is 0. Because this whole expression here can potentially change from being positive to negative when the bottom is equal to 0 or when the top is equal to 0. So we can rewrite this expression here as x divided by 2x minus 1 times x plus 4. If you're not sure about how to go from this to this, you could use the AC method, doing the 2 times negative 4, that's negative 8, and then if you can't remember how to solve, to factorize quadratics, you'll have to go back a few sections to revise that. In any case, you get this expression here, and this would be equal to 0. Well, the top would be equal to 0 when x is equal to 0, and then we're also interested in when the bottom would be equal to 0, so when x is equal to a positive 1/2 and when x is equal to negative 4. So the roots and asymptotes for that thing would be negative 4, 0, and 1/2. This word asymptote, the asymptotes occur when the bottom is equal to 0. And we'll look at that in more detail later when we're looking at the graphs of functions. Now, we put on those roots and asymptotes, negative 4, 0, and 1/2, onto the sign diagram right here. If we do that, it looks like this. Then we begin to check what happens if we take a value of x that's less than negative 4, somewhere over here. If you take a value of x equal to, for example, negative 5, the top is going to be negative, the bottom is going to be negative, well, sorry, the 2x minus 1 is going to be negative, and the x plus 4 is going to be negative. You could write that like this. We've got a negative on the top from, let's say, negative 5 on the top. We've got this part here being negative, and we've got this part being negative. Negative divided by what's going to be a positive on the bottom is going to give you a negative. And then nothing very interesting happens at negative 4. Well, actually, something very interesting happens, but we won't go into it in too much detail just now. We're going to kind of have, on the bottom, we're going to have a 0, and we're going to be dividing by 0, which kind of gives us an infinite answer, a positive or negative infinite answer. But we won't worry too much about that for the moment. Then you look between negative 4 and 0 in here somewhere. So you're looking at a value of x like negative 2, for example. If you try a value of negative 2 in here, the x is going to be negative 2. That's a negative on the top. This will be negative, and this will be positive. So it'll be a negative divided by negative times positive. If you try that, you'll get negative divided by negative times positive. A negative times a positive should give you a negative. So it's going to be a negative divided by a negative. That's going to be a positive. And then again, for 0, we're going to get positive or negative infinity. Between 0 and 1/2, we're going to choose, for example, if you choose a quarter in here, it's going to be positive on the top, it's going to be a negative right here, and it's going to be positive here. So what we're going to have is a positive divided by a negative, and altogether that's going to be negative. Again, for a half, it's positive for negative infinity. And then to the right of a half, somewhere over here, for example, choose x equals 1. We're going to have positive on the top. X equals 1 is positive. 2 times 1 minus 1 is going to be positive. 1 plus 4 is going to be positive. So it's positive, positive, positive. That gives us positive over 2 positives. That gives us a positive. So then we're looking at when this whole expression here, which is the same as this, is less than 0. So we're interested in this zone and this zone, where the whole expression is going to be negative. So that whenever x is less than negative 4, for this part here, and also whenever x is between 0 and a half, right in here. Now this is a similar kind of example. We're going to need to make this expression, this inequality here, we're going to need to shift things over to one side and make it bigger than or equal to 0. So the first step is just to do exactly that. We're going to have to subtract 1 over x minus 1. Then we're going to need to try to put these together if possible. So we're going to need a common denominator here. That common denominator is going to be x minus 3 times x minus 1. Right, so we're combining these two fractions together to make one big fraction. The next step is going to be to try and simplify this thing on the top. If you do that, well, you're multiplying out the brackets. We're going to get 2x minus 2 minus x plus 3 on the top. That's going to be, if you simplify that a little bit, that's going to give us x plus 1 over x minus 3 times x minus 1. And that had to be bigger than or equal to 0. Okay. So effectively, we've turned this expression here into this expression here, just by combining the two fractions together. Now, if you look at this expression here, we need to be interested in when the top is equal to 0 and also when the bottom is equal to 0. The top is equal to 0 when x is equal to negative 1. The bottom is equal to 0 when x is equal to 3 and when x is equal to 1. Okay, so those are going to be our roots and our asymptotes. Okay, so we're going to put them in the sign diagram below. And then, same as we did before, we've got to test a value of x that's to the left of negative 1. So, for example, you could take negative 2. If you take negative 2 and you put it in the top, that gives you a negative on the top. Negative 2 minus 3 is negative 5, that's negative. Negative 2 minus 1 is negative. So what we'll get in a case like that is negative over the two negatives. That gives us a negative. For negative 1, again, on the top, we're going to get 0. So 0 divided by anything is going to give us 0. So in a case like that, it's just 0. We need to test a value between negative 1 and 1. Well, you could test 0, for example. We'd then have positive 1 divided by negative times a negative. So we're going to have positive divided by a negative and a negative, giving us a positive. Again, for the actual root, it's going to give us either a 0 or a positive or negative infinity. Since the bottom is equal to 0, it's going to be an infinite answer that we're going to get. We then try a value that's between 1 and 3, for example, 2. If you try 2 in here, it gives us a positive on the top, a negative here, and a positive here. That means that we get this. And positive divided by a negative was going to give us a negative. Again, for 3, we're going to get one of those positive or negative infinities. And then we look at what's to the right of 3. So take a value like, for example, 4. If you take the value 4, put it in here, that gives us 5 on the top, 1 here, and 3 here, all positive. Positive, positive, positive. So we're going to get positive divided by the two positives, and that's going to be positive. So this equation here, this equation is going to be true at the same time as this equation is going to be true. So in other words, this whole expression is bigger than or equal to 0 when we have a value of x that's between negative 1 and 1, or a value of x that's more than 3. We're looking at when the whole expression is positive. So we can just write that down. It's when x is between negative 1 and 1, that's from this zone in here, or it's when we have x bigger than 3, this zone over here, where it's positive. Now, those of you who like writing things in another set notation, in another kind of way, might be interested in the alternative way of writing that, which is to write it like this. This means exactly the same thing. This means exactly the same as this thing here. It's the union of all the values from negative 1 up to 1, including 1. That's what that square bracket means. The normal bracket means that we don't include 1. And then this thing here means from 3 up to infinity, but not including 3. And the u just means it can be this or it can be this.